Ladies and gentlemen, we are live. It is 4 p.m. on Tuesday, 2nd of March 2021. That means it is time for a brand new epic product launch. Live from Mission Control in Northbike by the Sea, we have selected 6 epic members who each have an important development to announce to the rest of the world. Today, those companies are Femtum, UniKLasers, Nanoplus, Octlight, Cailabs, and Lytid. So let's open up the Zoom room and get started. Ladies and gentlemen, welcome to our monthly news show of Epic here from the Netherlands. It is almost springtime, the land of tulips. You see the beautiful flowers coming in. It is fantastic to bring a group of friends who have something new to announce to the rest of the world. Today we have 6 fantastic companies joining the meeting, and of course myself, I am Jose Pozo, I'm the CTO of Epic, this association who didn't stop working during these very difficult pandemic times. We are at the verge of being 700 members high, so thank you so much for all the support we are getting from the industry of photonics. Also, let me remind you that tomorrow is a very special day for Epic. We have our meeting on co-packaged optics, and we actually managed to get some of the top people in the world on this. We're going to have Facebook, Amazon, Intel represented in the room. It's going to be a fantastic meeting. I'm not going to be able to sleep tonight, so excited I am for this. But today is an amazing day because we have the product release of 6 fantastic companies. Femtum is going to be here to talk to us about the short pulse fiber lasers in the mid-infrared. UniKLasers is going to talk to us about the UV laser CW349 nanometer DPSS. We're going to have a presentation on Nanoplus, this time on mid-infrared LEDs in the mid-infrared wavelength range. Octlight is going to talk to us about fast 3D imaging. Cailabs is going to talk to us about ring shaping, beam shaping in the shape of a ring. And Lytid has a huge advancement for SWIR cameras with ultra high dynamic range and very low noise. So let's get the show started. Let's start with something really big that has happened in the field of short pulse fiber lasers. The company Femtum, here represented by the CEO, has a new product and is looking for partnerships on both sides of the supply chain. This is something very big in the mid-infrared wavelength range. Thank you very much, Louis-Rafaël, for being with us today and for releasing this fantastic product for the whole community through Epic. Louis-Rafaël, the floor and the attention of everyone goes to Femtum. Goes to you.
Thank you very much, Jose, for this kind introduction. I hope you see my slide now.
Crystal clear.
Perfect. So thank you very much. And I'm very glad to be here today to present you our newest product, the first microjoule fiber laser emitting directly in the mid-infrared. But first, let me tell you the story of Femtum. So 3 years ago, when we decided to found a company, we decided to go into the scientific community. We found out that researchers were using outdated and very challenging optical laser sources. Basically, they are wasting a lot of time in the lab. And right now, there's a strong lack of easy-to-use, industrial-grade, simple mid-infrared laser. And people want to do mid-infrared nonlinear optics. They want to do mid-infrared spectroscopy, mid-infrared silicon photonics. And they want to go into the mid-infrared because that's the region where you find the mid-infrared high absorption, so the fundamental resonances of most molecules. And as I said, because there's a lack of sources, then there's an opportunity to start up a company. So that's why we decided to start Femtum on developing mid-infrared fiber lasers. The first laser we decided to launch is the first femtosecond fiber laser emitting directly at 2.8 micron. Then we decided to do another improvement. So we developed the first amplifier directly emitting at 2.8 micron. And in this case, we can increase the power up to 5 watts average power, and we can amplify basically anything from CW to femtosecond laser. And then we decided to couple those 2 technologies together, and that led to the Femtum Ultratune 3400 series. It's a tunable femtosecond fiber laser from 2.8 to 3.4 micron. And this spectral band is of interest because you find the fundamental resonances of OH, so the water, of CH, the hydrocarbons, and NH, and many other molecules, actually. This system is really easy to tune. It's done electronically, so it's N-free, so it's pretty easy. So as we were developing this market and those technologies, new demand come for material processing. And let me tell you why. So if you look at the short pulse laser processing industry right now, you will find that the working horse, the best laser out there are ytterbium fiber lasers. And the reason why is that they get tremendous average power and peak power and at very reasonable cost. But of course, those lasers doesn't work for all the applications, and people need to use other wavelength when those doesn't work. And right now, the choice you have is to do parametric conversion and go to the UV visible, or you go in other types of fiber lasers, so at 1.5 micron with erbium fiber lasers, or at 2 micron with thulium fiber lasers. But you see that there's still limitation in terms of wavelength, and some applications, they need better absorption, better selectivity, and I strongly believe that you should now consider 3 micron fiber lasers, because basically non-metals absorbs a lot 3 micron wavelengths, and at those spectral regions, you get more selectivity than UV lasers. And today, I will present you the first industrial-grade fiber laser emitting directly at 3 micron. So it's now time to present you our newest product. I'm very proud of my team. We have worked very hard to launch this product today. And let me introduce you to the Femtum Nano 2800. It's the first of its kind. It's the first fiber laser emitting up to more than 100 microjoule energy at 2.8 micron. The repetition rate can be as high as 50 kilohertz. The wavelength, you can choose it between 2.73 and 2.83 micron. Pulse duration can be as low as 30 nanoseconds. We can increase that to more than 200 nanoseconds. And the M-square, very good, below 1.5. Because it's a fiber laser, you have fiber delivery, so it's really easy to plug it into your machine or your robotic arm. And the packaging is a standard rack mount 19-inch. It's also air-cooled, no need of water cooling. As you can see, this product is made for non-metal laser processing, for biological tissue ablation and scientific research. Today, I only have time to present you 3 applications for non-metal processing, which are pretty unique, and this laser makes them possible. So the first one is for fiber stripping. It's pretty hard to remove the polymer cladding of optical fiber without fragilizing the glass. And right now with our laser, we can do this by selectively ablating the polymer jacket, and that yields to very high mechanical strengths with high speed. And as you can see on the picture, the edges are very clean. We can do window strip and strip, and those laser processes are required for medical devices, for industrial sensors, or for telecom components. The second application I want to mention you is for semiconductor processing. Right now, people want to go through semiconductor and do back surface processing of other materials, so selective patterning again, or they want to do back surface processing of the semiconductor. And at 3 micron, because the wavelength, most semiconductors are transparent at 3 micron, then we can go through the semiconductor. And also we can do in-volume processing because we can use multi-photon absorptions. As you can see, these processes are very precise. Right now, it was a 30 micron diameters micro hole drilling in germanium. The last application I want to tell you about is for flexible or printed electronics applications. People need to do thin film ablation, and in this case, it was ITO patterning on PET. And as you can see here, the feature size is pretty small, so we can go as down as 12 micron, and we can even decrease that with better optics. And the ITO absorbs a lot the 3 micron wavelength, so we can do this with very high speed. And there are so many more applications that I cannot disclose right now. But of course, to conclude, if you're limited with your processing application, if you would like to learn more about the Femtum Nano 2800, we have our own mid-infrared laser processing lab in-house. So we can do a short demo for you. So you just have to send us your sample and we'll make a free demo for you. Go to femtum.com and complete the form. It will be my pleasure to assist you. Thank you very much.
Thank you very much for this fantastic product. It is great to have you here. I would like to ask you the key question. What's new? This is something new in the industry. How is this product is different from the rest in the market?
So in terms of wavelength, so there's no fiber lasers emitting at 2.8 micron in the market. So it's the world first fiber laser emitting directly high energy pulses, 100 microjoule. I've never seen that in the market. If you look even at the biggest players in the world, nobody is doing that.
We are talking about three different application fields in your presentation to talk about non-metal processing, biological tissue ablation, and scientific research. Let's go to the first one, non-metal processing. What kind of applications do you want to target within this non-metal processing? Who are the main system integrators, potential clients that you would like EPIC to bring you in touch with?
Yes, it's a very good question. Actually, we are looking for system integrators, so people doing micro machining. So all the micro machining system integrators, we are looking for you to collaborate and develop new laser process. I would say, generally speaking, selective ablation of, let's say, polymer on glass. This is a very cool application. Polymer on semiconductors or any types of selective ablation. Then I think those lasers are made for that.
I was very amazed by this slide that you show here when you talk about the industrial applications that you are targeting. And one of these industrial applications was fiber stripping. In many different application fields, we are now talking about the specialty fiber for different harsh environments. Is that, to what extent this is a market that you want to address with your laser? Is it something that is perhaps a niche market, or is the main one of the main application fields for you, fiber stripping?
So right now it's a niche and main application. So we want to differentiate by going into place people don't go. And right now our laser can do the job, and we achieve results which are very unique. No other lasers, even CO2 laser doesn't work for that. So basically, yes, you're right. Specialty optical fibers are all to strip as well. We can make free demo for you. It's just that there are so many types of fiber that we try to make the more classical polymers right now. But if you have a PCF fiber or any other type of fiber, we can try it.
One more thing. So this one is a bit more difficult question for you. So in previous meetings, we had lasers for semicon being addressed, and we had companies like ST Microelectronics and Infineon evaluating the use of femtosecond lasers. And the first thing that always came back was throughput and processing speed. To what extent you think this is a limiting factor? Are you considering multi-beam solutions, or do you think this is something that is the system integrator the one who should be worried about?
It's a very good question. So this application is really at its infancy. Of course, in terms of throughput, you need to do multi-beam, and there's many technologies with beam shaping you need to do. We are looking for partners to develop this application for sure. I cannot really disclose the throughput because we need to get a lot of samples, and you have to make a lot of statistics. But at this point in time, we are looking for partners to develop this application.
We have a question in the room coming from Lisa Lasers. Samir, thank you very much for being with us today. What's on your mind?
Yeah, hi everybody. I'm curious about the pulse peak power of your fiber laser. Maybe you can comment on the maximum available pulse peak power. And congratulations to this very nice and promising fiber laser device.
Yeah, thank you very much. Of course, it depends on the pulse duration, and in the simple answer to that question is we have peak powers in the kilowatt range, multi kilowatt range for sure, and it depends on pulse repetition rate, on pulse duration, and a lot of parameters, but it's in the kilowatts range.
Wow, impressive! Thanks.
Lisa Laser is one of our key members in developing holmium laser and thulium lasers, mostly for the medical market. Thank you very much, Samir, for being with us. We have another question in the room. This one is coming from Canada, from Polytechnique Montreal. Denise, thank you very much for being with us from Canada. What's on your mind?
Hello, hello. Just a quick question for Louis-Rafaël here at Femtum. I'm curious, so you have this excellent source that you're now presented, but I'm in academic research. I'm interested to cover more into the mid-infrared and perhaps even far infrared. Are you thinking of offering supercontinuum solutions in the near future? Thank you.
So it's a very good question. It always depends on the output types of supercontinuum you want. So do you need it to be coherent or incoherent? Nanosecond pumping leads to incoherent supercontinuum. So if we would like to go to coherent regime, and I think it's your case, Dennis, you would need to go with femtosecond laser. So the first products I shown you would lead to those supercontinuums.
Thank you. Thank you very much, Louis-Rafaël. 2.8 micrometer femtosecond lasers first in the market. Congratulations to Femtum. Let's continue with the program now, and we go to our second speaker. We go to Scotland. We go to UniKLasers. They're going to talk to us about a world's first single frequency ultra narrow line with 349 nanometers DPSS CW-UV laser. Thank you very much for being with us from UniKLasers, a vertically integrated company. When you go there, you see the entire manufacturing chain. One of these companies that I know is the success of Europe in their hands. The floor and the attention of everyone goes to Johnny Bray, the head of sales of UniKLasers. The floor is yours.
Hello, Jose. Can you see my screen?
Crystal clear.
Fantastic. Thank you very much for the introduction. And hello to everybody. Welcome to my home on the east coast of Scotland. It's probably the most strangers I've had in my house for about 18 months. So I'm excited to welcome you all. I'm going to give you a short introduction into my company, UniKLasers, and a short overview of some of our technology, and then finally the new product I'm here to announce, which is the world's first single frequency continuous wave DPSS laser operating at 349 nanometers. As a quick introduction into who we are a small but growing company based in the capital in Scotland. As a personal note, I joined the company on the back of both private and national investment in the past 12 months. Incidentally, probably the last time I had a haircut as well. We've moved into new premises. We've looking to commercialize now some of the research that we've been doing for the past few years since our foundation. What we specialize in is the development and now production of continuous wave single frequency DPSS lasers, diode pumped solid state lasers. And to do this, we use our patented BRAMS technology, which I'll explain to you in a few slides' time. What it allows us to do is to create these solid state lasers with a very small footprint, very, very high stability, both spectrally and in power, at very, very low line widths. So as a quick background, we were founded by Professor Fedor Kapushko, the rather disappointingly handsome young man standing on the left of this photo, next to Professor Stepanov and Professor Prokhanov. Professor Kapushko has been involved in lasers literally since their invention by my man back in the 50s. He has over 150 publications, and it is this BRAMS technology that is the culmination of all of these years of research that UniKLasers was founded to commercialize. Historically, a research company, we have a wide academic, commercial, and national partnership. So we work well with large corporations. I'm sure we all know well within the EPIC network, people like Fraunhofer and Teledyne. We have a lot of funding from people like Technology Scotland and Innovate UK, and we work widely with a wide number of academic partners as well. Not least to mention the EPIC network. Our company is founded on BRAMS technology, so we have a simplification of our laser cavity here. Both the reflectors overlapping the gain media. You have a non-linear crystal, which is an optional step depending on which frequency you're looking to produce. And BRAMS technology in particular is this section on the right-hand side. We use a volume Bragg grating to restrict the number of possible modes coming from the gain media. And then we use quite old technology, a Michelson interferometer, to finely tune this reflection and limit the gain media to just a single longitudinal mode. We then lock this using a tilt locking mechanism with these mirrors that control the cavity length. This gives us a unique method of single frequency generation. It allows us to skip some nonlinear steps. We can have more direct access to lower wavelengths, which gives us higher power and higher efficiency. And we also have very highly stable products in this way. So currently, the combination of our research over the past 7 years has allowed us to produce a number of different wavelengths. To give you a few examples, we have our Solo 1064. It has a very small footprint. It's around half the size of a piece of A4. A solid state laser producing up to 2 watts of output power with extremely low line width and extremely high stability across its range. As we move down through the wavelengths into the 640, we can see we maintain these specifications, and an example of the performance along the bottom over 24 hours, we have this very high wavelength and power stability, and also excellent beam quality as well. We have lasers at 532, and all of these are used in a range of different environments. I know all of us like to look inside academic labs, so here's an example of one of our customers in Germany is using the very high spatial resolution of our lasers in conjunction with confocal microscopy and Raman spectroscopy to return very good results. The one thing I haven't mentioned is our quantum technology. Our main research basis is around quantum technology and quantum sensing. So the continual improvement, miniaturization, and increased reliability of these narrow line width sources that are suitable for different quantum technologies. And commercialization of this research is really what our products that I'm introducing to you today are founded on. Last and not least, as a concept of this technology within the UV range, we've released the Duetto 349 laser series. As a quick oversight into our naming conventions, you notice we have the Solo and the Duettos. The Solos are direct laser sources. There's no non-linear step, whereas the Duetto, the 349, gives you the idea that we can access the UV region using just one non-linear conversion, which allows us to keep the footprint very small and also allows us to have very high energy efficiency as well. I showed you some power stability before, ran over 24 hours. Here's an example, ran over an entire weekend. So something like Friday afternoon to Monday morning. You can see we have this very, very stable output power of less than 1% and this unbelievable wavelength stability of just 0.06 picometers across 65 hours. The whole unit has been arranged and designed for this type of integration to different systems. The wavelength gives us access to a wide range of applications, both industrial and academic. We've made some considerations for the coronavirus. We have remote diagnostics and software control. We do not need to travel to connect to the laser. And we also have very long operational lifetime as well. I hope that gives you a quick background into the company and the products we produce. Thank you for listening to me. I'm happy to answer your questions.
Thank you, Johnny Bray. Johnny.bray@UniKLasers.com. Please send him any kind of request for this fantastic two products that he presented. I would like to go first to the, Solo 1064 laser series. I'm going to ask you the same question I ask all the time. This is a product release. So how is this product different from the competition?
Yeah, so the main uniqueness, and this is a pun that I am contractually obliged to make at least twice every presentation that I do for UniKLasers, is our technology basis. So we use our Brahms technology to produce very high power at very low line width, very narrow line width at single frequency. And this combination of small footprint, high output power, and very narrow line width is what makes our lasers unique to other lasers on the marketplace.
You have defined for the Solo 10, well, actually, maybe I should set the screen. For the Solo 1064 laser series, you have defined microscopy as one of the particular application fields. From all these different application fields that you are targeting, which is, in your opinion, the 2 or 3 main ones, and what kind of system integrators you think EPIC should bring you in touch with?
Yeah, so in particular, the new product launch of the Duetto 349 really opens up the variety of applications that we could target and focus on. So the specification of narrow line width obviously lends us to applications where high energy selectivity is important. But as we move down through the wavelengths, which is very much where our product map is headed, down into higher energy and lower wavelengths, we can use this spatial selectivity as well. So the example that you gave of microscopy is an ideal type of application for these type of laser sources, especially down at the lower wavelengths. So things like high resolution Raman spectroscopy, where you need very good spatial control over your feature size but also clever control in the Z-axis as well, using a highly controlled, precise laser like the ones that we produce is ideal for these types of things. So
we talk also about the area where you are, Glasgow, and quantum technologies. There's been a huge amount of developments on quantum technologies in Scotland. What is the key application field that you are targeting? Is it an atomic transition for atomic clocks? What is the one or two maybe applications in quantum technologies that the researchers in the room should really contact you for buy your laser?
Yep, so quantum sensing and metrology are the particular applications that we focus on. So I know quantum technology is an area of great excitement. We know that it will be implemented across many different areas in the next, depending who you ask, 3 to 7 years perhaps. And you read the BBC and other news services where you see groups of university students wheeling out gravity detectors out into the field, and these types of things are finding lots of applications in building and oil and gas and exploration and archaeology. Our national research projects are designed to allow us to provide a light source that is suitable, small enough, robust enough, and with the correct specifications to fit into these type of applications.
You write down in the calendar next week on Friday, the EPIC Quantum Technology meeting on quantum microscopy and medical technologies. Write that down because that's important for you. Congratulations. I would like to highlight that UniKLasers is really a vertically integrated company. They do all the manufacturing in Glasgow, and they're always looking for partners. So this is a huge opportunity to collaborate with what is becoming a success story on the DPSS lasers. Johnny, once again, thank you very much. Let's continue with the program. We have our third speaker already waiting to show us something really big again in the mid-infrared. We go to Würzburg in Germany. We go to Nanoplus, a company that has been defining a specific laser for every wavelength. And today they're going to talk to us about mid-infrared LEDs from 3 to 6 micrometers. Lars, thank you very much for being with us from Nanoplus. Thank you very much for being such a huge success story for the European ecosystem on mid-infrared technologies. And thank you very much for keep coming to the EPIC meetings looking for partnerships. The floor and the attention of everyone goes to Lars Hildebrandt, goes to Nanoplus. The floor is yours.
Yeah, thank you, Jose, and EPIC team for giving me the great opportunity to show what we're doing. Well, I'm going to show you two news pretty much. One is the mid-infrared LEDs, of course, the product, but the second one is also a new company that we just founded, which is Sensorlight Technologies. So it's not working.
It's all good. Yes, we see the pointer, we see the slides, all perfect.
I'm already changing the, oh, now you can see it here. So Nanoplus is always has been a vertical integrated company, and that has always been the strategy of Nanoplus to really have everything in-house. So we do the material design, we do the simulation, and then of course all the epitaxy here. We have 3 MBE system running molecular beam epitaxy to grow the parts. And then we have all the device processing in-house. Some of the parts are doubled. We have them in mining and we have them in Gaborone, like e-beams and all the technology to checking if everything is working, the quality issues. And then the device mounting here, for example, is fiber coupling. And then here we have all the robots in-house to do the checking. So the operator, she just has to place the parts into the machine. So we are at the moment rolling out our long-term strategy to manufacture in Europe, pretty much. So what you can see here is where we're starting here is this fixed point analysis. So this is the tunable diode laser spectroscopy market Nanoplus always has been in. We grew the company to 100 people in the last 20 years. So the next step for us really would be to get at this point of care portable devices thing with larger numbers, tens of thousands of instruments or tens of thousands of sensors, finally for end customers, and then to go to even larger market in the automotive industry and medical applications. So that is part where Sensorlight technology kicks in here at the upper left corner, which is really dedicated to high volume applications. So if you come to Nanoplus and you want 10,000 or a single one or 10,000 pieces. That was all done by Nanoplus. But if you go to larger numbers, cheaper prices, high-end quality, you will pretty much end up at Sensorlight Technologies. So having said that, coming to our customers, at the moment, most customers are really doing gas spectroscopy in the whole field between 760 nanometer. We have an oxygen line, for example, here, to the high-end range. So I'm talking about this wavelength range where you have all the very interesting gases, methane, ethane, CO2, NO, NOx, CO, etc. And they have the fingerprint here with very strong absorption features. This is what most of our customers are doing. Well, as I said in the introduction, we have everything now which emits a photon pretty much from a semiconductor device. So starting with a DFB laser, with very small bandwidth, very small line width, 760 nanometer up to 14 micrometers. Fabry-Perot laser, if you need a broader range, you can do the same without a DFB grating. We're offering here up to 1 watt for pumping purposes, a little bit of material processing, OCT, things like that. Then the SLDs, if you don't like to have a small bandwidth source, you'll pretty much go to SLDs. Here we have 760 to 2.9. We will also start to do this in the mid-infrared range, and now new in the mid-infrared range, I'm presenting the first time that there is a CW mid-infrared LED. We can offer every wavelength between 2.8 and 6.5 micrometers. So just quickly, DFBs. As I said, we have normal DFBs, diode lasers, interband cascade lasers, and quantum cascade lasers at several housings, small bandwidth. Then the normal LDs, Fabry-Perot laser diodes up to 1 watt. We also have smaller power if customers require that. And then finally, SLDs. Here, up to 10 milliwatt of output power, customers who want to have a small footprint and avoid coherence. And then the MIR LEDs. It's true CW, so it's not a quasi CW like some customers, some competitors in the past had. Relatively high output power. At the moment, we specify more than 1 milliwatt at a very low power consumption. Here you can see a chip with 2 milliwatts. We also have seen 4 milliwatts, so there's more power to come in the future, I think. We can do custom-specific solutions. So here in the lower right corner, you see our ceramic mount. There's other various packaging options available. This is something for future cooperation and to really check what our customers require to have from us. What I want to share here is our webpage. So you're very welcome to have a look at our webpage. I think I have to share this.
We see very black webpage.
Yes, I have to share this one as well, which is this one here.
Let's see.
Can you see it now?
No, not yet. I really want to see it, but everybody, in the meantime, I want to address them. You can go to nanoplus.com and see the website yourself. Do look, I will share it from my computer.
Maybe.
But before that, you came to an EPIC meeting. You came with mid-infrared LEDs. I do know, because we discussed about the huge market pool that you are getting on these mid-infrared LEDs, and congratulations.
Thank you
Makes
very
me
much.
extremely happy.
Thanks,
What application fields are we targeting with the mid-infrared LEDs on 3 to 6 micrometers?
I think it's still gas spectroscopy mainly. So many customers, they have a need for a very cheap sensor, right? So something which is very wearable, you can, well, drive around with in your car, put in your home, things like that. And that has to be extremely cheap. And the MIR LEDs, they can be produced to very low cost if it comes to volume. So that's one of the main targets. The other could be illumination because of the high power.
in the previous meetings, when we talk about mid-infrared photonics, it was very clear that the quantum cascade lasers had to, for addressing some of the application fields, there had to be a paradigm shift on the cost, and that would be targeted by actually increasing the volume, because a piece of semiconductor.
Absolutely.
Which applications do you think can be benefited on the sensing side by using LEDs or also superluminescent diodes?
It's hard to say. So when you really have small bandwidth lasers, right, quantum cascade lasers, and then a DFB quantum cascade lasers, they are small bandwidth tunable. But these will most of the time be a little bit more expensive. So it's really the cost driver, right? So you can produce these chips, I would say, to maybe 10% of the costs of a QCL, even in volume. So that is the main driver for the MIR LEDs.
One thing that is, you said Nanoplus is a vertically integrated company and is a success of this industry, but nobody can do anything alone anymore. In terms of partnerships, could you give me an item on the Santa Claus Christmas list of a partner that would find you that could actually make Nanoplus even greater than already is?
Yes, the MIR LEDs are not hermetically sealed yet, so they're open. So we are searching for someone who can give us a packaging which is really mass producible. And I'm not talking about, oh, this costs 10 euro. 10 euro is too much, right? And can do a hermetically sealing of this high heat load package. That's the problem.
Hermetic packaging for lasers, also of course for the LEDs and for the superluminescent diodes.
Yeah. We do the package ourselves, but to really have something where you say, okay, this is the ceramic submount, this you put on top, and then everything is sealed or collimated.
I have here for you and for the whole world in YouTube and in the Zoom room, the website of Nanoplus, nanoplus.com. It really is very good when it comes to the different applications they are targeting, and have a look also at the library.
If you look at products and then go to MIR LEDs, there's tons of information, also papers and things like that. So just go to webpage, download the data sheets, download the file from there. Everything's there.
On talk to my friend Lars, who's done a fantastic job at Nanoplus. Congratulations once again for being that big success story. Anybody who wants to be ahead on the mid-infrared range, talk to Nanoplus. They really have helped so many EPIC members on this different wavelength range. Let's continue with the program, and now we go to one of my favorite members of EPIC, because now we're going to talk about optical coherence tomography. We're going to talk to OCT Light. Thor is here to talk to us about a new product. This new product is a fast 3D imaging with megahertz swept source VCSEL. Thank you very much, Thor, for being with us today. And thank you for coming here with this new product, looking for partnerships, looking for collaborators, and looking for system integration. The floor and the attention of everyone goes to OCT Light.
Thanks a lot for the kind introduction, Jose, and your great enthusiasm. I'll try my best to counter it and present to you our new product announcement here, which is a fast megahertz swept source VCSEL for 3D imaging. So OCT Light wants to become the preferred partner for VCSEL swept sources, and we are a born global photonics company from Denmark, Copenhagen, this photonic cluster, where we have commercialized a unique VCSEL technology for swept source OCT imaging. And our primary purpose for that have been that our eyesight is important to all of us. And with our technology, we want to help improve vision. So we do this by offering this unique VCSEL technology that enables 10 times faster imaging speed and range, which enables wider field of view for seeing more eye diseases like diabetic retinopathy, and full eye imaging for more precise cataract surgery, where the natural lens is exchanged with an artificial lens, and you can become free of glasses. We want to do this by bringing this key enabling VCSEL technology into your hands, and we have done this by introducing the Cailabs VCSEL swept source platform. For the last couple of years, we have been working in a Eurostars funded project on developing a technology that achieves live 3D optical imaging for improving these two topics I presented earlier. So today I'm very happy to introduce our new product, which is the Cailabs Hero. It's based on our patented Hero technology, which is this unique VCSEL technology that enables the fastest scalable solution for 3D OCT imaging with blazing megahertz speeds and single channel acquisition that allows for this megahertz A-scan image acquisition with K remapping. It's a laser module at 1060 nanometer with 10 to 25 milliwatt of single mode output power, which is single mode tunable 40 to 50 nanometer at 1.7 megahertz with a very long coherence length. And most importantly, it's in a compact and scalable platform that can really be driven out into the hands of end users that are the medical doctors helping us diagnosing and treating eye diseases. So I'll be very happy to get contacts from you with any requests and questions you might have, and also following up here. Thanks a lot for your attention.
I would like to recommend everyone sales at octlight.com. Octlight has been looking for partners in the medical segment already for many years in EPIC. Thank you, Thor, for being such a committed member of EPIC, and thank you for releasing this product to us. So I'm gonna ask you the same question I asked the previous speaker, so no surprise here. When it comes to the Hero, to the Cailabs Hero, how is it different from any product in the competition?
So the truly unique thing about the Cailabs Hero product is that we have a patented vacuum package technology for achieving these very high speed with such a high stability that you can use a single channel pre-calibrated for OCT imaging. Usually you will use 2 channels for both acquiring the OCT signal and a calibration signal, but that is not required with our technology. And secondly, our technology enables these megahertz speeds in a compact and scalable platform.
Let's talk about applications. Of course, if there are any questions in the room, please do so, but let's talk about applications. One of the key things here is that you manage to have very stable wavelength tuning from 40 to 50 nanometers in the 1060 nanometer central wavelength. You are targeting OCT, LED, OCT light sources. For what application fields?
So of course we're extremely excited to bring this into the ophthalmic application, but there's numerous other application which we're very interested to explore, and there's many technologies for 3D optical imaging. This technology has some unique properties in terms of the very fast sweep speed and also the possible miniaturization. So we are looking for applications from everything from ophthalmology through cardiovascular imaging, material imaging during non-destructive testing, laser material processing, to automotive imaging, other topics like that. So
the large coherence length that your laser has, it actually enables to do this even for the semiconductor industry. You don't need to be very close to the target, and that's for me, in my opinion, the biggest thing from this. But I would like to ask you, because you put it even in the title, you're using VCSELs, and one thing that for me is clear is about the compactness, and also clear about the scalability in put into volume production. So when it comes to this very ultra high volume production, I'm not going to ask you about cost because I'm not allowed, but what kind of partners would you like to partner with to take this into the ultra high volume productions that a VCSEL based light source is dependent for?
So we are very much looking for partners in the whole ecosystem, and I think it's exciting to be part of an especially strong ecosystem in Europe, where we are already working with several partners, and we are interested in working on everything from the source material, the VCSEL material through packaging, and the final system testing and qualification, where I know there's a lot of expertise in doing this, which is something we're working on setting up. So I'm sure there's a lot of people out there that we could collaborate with.
Definitely. And we have a question in the room, perhaps from our potential collaborators. A question from Cailabs Laser Systems. Nariman, thank you very much for being with us today. What's on your mind? You are muted. Please unmute yourself. I have a Mac to celebrate that event.
Do you hear me now?
Loud and clear.
Okay, great. Yeah, I have a question. I have a great respect to medical applications in the photonics, and I would like to know how much effort is necessary to overcome all the medical regulations and directives in time. I mean, how much effort do you put into this regulations and directives to make your business run finally? Thank you.
That's a really great question, and it's something that's been to our attention from the very start. So we are supplying the laser module for system integrators, and therefore it was very important for us to understand what requirements they had. So we have a safety interlock that is provided to the system integrator, which is redundant and satisfy the requirement for building in such a laser in a medical system.
Thank you very much. We have another question in the room. This is from a friend of Epic, Valid Atia from Atia Consulting. Valid, what's on your mind? You are muted. Yes.
Okay, yeah, Thor, I was just wondering what limits the tuning range to 50 nanometers? Can you achieve closer to 100 nanometers that's needed for retinal imaging?
Yeah, so there's some limitation in the material used in standard VCSELs, which limits the tuning range to around these 50, maybe 70, 80 nanometers. And with a change in some of the parts of the VCSEL, it's possible to extend the tuning range up to just above 100 nanometers. And this is something we've been actively working on. Right now, our focus is to get this out to offer these megahertz imaging speed, which is unique in applications where the 50 nanometer would be adequate.
Thank you very much, Valid, and thank you very much, Thor, for this. All the best. I'm sure that the future is very, very bright for a company like OCT Light. And let's continue with this program. Fantastic event so far. We're going to talk now about beam shaping. And when it comes to beam shaping, there is nobody better than Cailabs. Today, they have something big to show us. This is something big. It's a unique product. They are doing ring shaping. They are going to do beam shaping in the shape of a ring, and for that they call it a CANUNDA-HP. I call it an amazing beam shaping technology. All the way from Caen in France, Gwenn Pallier is here to illuminate us from Cailabs. The floor and the attention of everyone goes to your ring shapes. Goes to you.
Hi. Good afternoon, everybody. I'm really glad to be here with you. Thank you very much, Jose, for the kind introduction. My name is Gwenn, and I'm working at Cailabs, and I'm really, really pleased to be here today to release our CANUNDA-HP ring shaper with all the EPIC members. So let me start with a few words about the company, Cailabs. We are actually a French company doing beam shaping. So we try to do beam shaping for a lot of different applications, all based on MPLC, our unique technology, which actually stands for multiplane light conversion. It's actually a new way to think light propagation because it's very innovative. It's been patented from the beginning, and we actually do work worldwide. We have partners all over the world in terms of sales or in terms of customers or partnerships. Over the years, we managed to raise nearly 17 million euros, which in one hand did enable us to hire a lot of talented people, and we are nearly 60 today in the company. And on the other hand, we managed to develop ourselves on a lot of different markets. So we have actually done telecommunication, local network telecommunication, as well as space communication. We have also worked on some custom topics such as defense topics or medical topics. But today we are here to talk about laser material processing, which is also one of our product line. Here is actually one of our family picture of the off-the-shelf product of the Canunda product line. Canunda is actually the product line where we want to improve all the laser material processings. So the systems on the bottom of the pictures are the old members of the family. It's Canunda Pulse, Canunda Axican, and Canunda Split. These systems are made to improve pulsed processes. It can be femtosecond laser material processing, or it can also be up to nanosecond processes. But today, I'm actually here to discuss about the first member of the off-the-shelf products for CANUNDA-HP. We have done a lot of systems for high power applications, CW kilowatt lasers in the past, but we didn't have any off-the-shelf product. And today we will discuss about the one you can see at the back, which is the CANUNDA-HP ring shaper. So I'm really happy to release it today. So the system actually is having a standard connector as an input from Precitech, and it's having also a standard optical window and crossjet at the output. In between, that is actually what is really new. We have an actual fully integrated laser head, which is Cailabs MED. It's made in France, made by us, the whole system. So we have a collimation mirror at the beginning, then we have 3 shaping mirrors, and at last we have 1 focusing mirror, and all of them are actually water-cooled, and this is very important to understand what is really unique with this product in the next slides. So when we develop products for material processing, we want to target the industry. So we want to really look at the environment, have systems which are compatible with the industrial environment. So the system is having pretty standard dimension and weight, knowing that we actually target the laser beam welding market. And it's integrated with a standard laser from Trumpf. And what is also very important to notice is that there is absolutely no alignment. This is a plug and play system. You just plug it in on your arm robot and you can weld. We also do provide some process monitoring captors or some add-ons to ease the process. What is really new, actually, it's its performance, optically speaking. So the system is fully reflective, as we are always doing in Cailabs. And it actually means a lot of things. We can have a very homogeneous cooling at the back of the optics, and that enables a very stable operation. And we do have a ring shape up to 16 kilowatt. We have demonstrated already, and we actually believe we can go even further. This is really unique, having the beam shaping associated to such a high power. Moreover, which is really unique, we have no more focus shifts. This is due to the reflective design and the MPLC technology. We managed to have 0 focus shift up to 16 kilowatt. This is really an important point to ease the process. In addition of that, we are a beam shaping company. So we also have target to have a nice shape. It's a very small ring. And what is also very unique with that ring is that we managed to preserve the depth of field of the input laser. So we have the very nice ring shape over a high depth of field of plus or minus 3 meters, which is actually pretty big. Because I like videos, now you should see also a video on the bottom right of the screen, which is some tests we have done of laser beam welding. But because we have only 5 minutes, I will get to the conclusion already. What message should you take home regarding that product? Well, we have provided a fully integrated laser head. It's actually delivering a ring shape and based on our unique technology, MPLC. The system is already handling 16 kilowatt, and we believe that we can actually even handle more than that, which is really unique on the market. You have no more focus shift at all, thanks to the reflective design. And I would have loved to show you some more results on laser beam welding, but the time slot was too small. And I invite you to contact me if you want to have a lot more information about the laser beam result that we have had with Institut Maupertuis, and we will host a webinar with them in 2 weeks. And I will just conclude by saying this ring shaper is available off the shelf, and we are glad about that. And I would be really happy now to answer all the questions you would have.
Thank you very much, Gwenn at cailabs.com. And you know, Gwenn, the first time I met Jean-François Morissour, and he told us about the technology and the idea of beam shaping, and now I see a laser head collaboration with Presitech using Inga Trumpf machines. You are a story. You are a story that I want to tell everyone. I'm quite amazed of being part of this. I think we have a lot of questions for you. So the first one is gonna go to Antonio Raspa, Innovation Manager at Epic and a person with 30-year experience in the laser industry, Quanta and Trumpf. Antonio, what's on your mind?
Oh, first of all, I'm really impressed because yeah, this device, this optical head is showing no limits. So 16 kilowatts is a huge amount of power, but looking on the geometry, there is no limit. So if I can say you can double it without thinking, just in a minute. The same optic can handle, I guess.
Or double it actually, the thing, you mean in terms of power?
Yeah, you have just...
Yeah. We will try 24 kilowatts very soon, but the thing that there are not many 24 kilowatt lasers. So for now, we have tried only up to 16 because we had only up to 16 kilowatt available. So we are happy to look at higher power, and we believe that it shouldn't be such an issue. So very probably in the next 3 to 6 months, we will have results at 24 kilowatt, maybe a little bit more than that, because I mean, we have to have the laser first. But yes, actually increasing the power is not so complicated because it's fully reflective.
Thank you very much. Gwenn, back to you. So when I see this slide and I see this beautiful, beautiful ring, the first thing that comes to my mind is what makes your beam shaping technology different, unique than the competition?
It's an excellent question. Actually, ring shape is not really original. We have to admit that because the truth, you have already the double core fiber technologies which are providing that kind of shape. But the thing is that you have to change your laser. You have to buy a new fibers. In this, with our technology, you just have to change the laser head. It's the same price as another laser head, and you have the beam shape which is actually done. In addition of that, we have two main advantage, which is the handling of the focus shift and the very high depth of field. Why then did we look at ring? I want just to answer that one also because we have competitors when we do a ring shape, but the thing is that the ring shape is very convenient for a lot of applications. So when you do your first off-the-shelf product, you want to have a product which is addressing as many customers as possible. But we will have also other off-the-shelf products coming with more original shapes because our technology is actually make it possible to have very weird shape like asymmetric shape, for example.
I've discussed in previous meetings about the flat top, about the asymmetric, about the line. I am quite amazed of what you can do. And also I would like to highlight here, well, I would like to ask you first, when it comes to the ring shaping, tell me about 1, 2, 3 applications that you would like to discuss with the system integrators that are going to come knocking on your door.
The first one I really want to discuss would be additive manufacturing. That's something we want to develop more in 2021, and we are really looking forward partners who are keen into modifying their machine to try new shapes, because you have definitely to change the machine to introduce the beam shaping and see how it works. And we believe that the market will grow a lot and that there is a lot to do with beam shaping. I guess it's the main one. Then otherwise, we are looking at a lot of different applications, and I'm always happy to look at things that we have not looked at in depth. For example, we would be happy to try this shape in terms of laser cutting, see how to improve things in terms of laser cutting, even if I know that probably the head would have to be a little bit lighter, but the truth is that we have not tried to make it lighter yet, so we will do it also in the future.
One of the things that I always compliment you is because you always choose your partners. Also, you always choose them within the Epic membership, and having the Presitech and Trumpf and also the collaboration with other many laser companies had made Cailabs a very unique, innovative, and a success story. Congratulations, Gwenn. Congratulations to the whole Cailabs team. And thank you for bringing this super innovative product to this product release. And we are going to now go to the last speaker of this fantastic session. I always say we save one of the best for the last because I love you all equally. This is something very unique. We have a very ultra high dynamic range, very low noise SWIR, short-wave infrared camera here, looking at different application fields, especially in the scientific market. From Lytid, Mingming is here with us to tell us how we can all help this new company develop these SWIR cameras for the different industries. Mingming, thank you so much for being with us today. The floor and the attention of everyone goes to SIRIS, goes to you.
And thank you, Jose, for the nice introduction. I'm Mingming, sales engineer at Lytid. Today, I'm glad to present you our new product SIRIS, a high dynamic, no noise, and deep cooled scientific SWIR camera. Let's begin with the introduction of our company, Lytid. It is founded in 2015 in Paris by Dr. Pallier and Jean-Jacques Roche. As you can see here, we have many partnerships with the top laboratory in France. Our first product, terahertz QCL laser, has won the 2016 Primes Award, and we have participated in the European project Horizon 2020. Being a young company, we are quite proud of our accomplishment in the latest year. And by taking advantage of our scientific background and know-how, we transform the up-to-date research result to the available product or solution on the market for the end user. At the very beginning, Lytid is focused on the terahertz device. We have proposed the two state-of-the-art source detector and terahertz optic. Thanks to those experiments, now we can provide the terahertz imaging system. Here you can see one of the imaging results. As you can see, it's real time and it has a high resolution. We can also propose optimize the system for the application of the customer, driven by the increasing needs of the customer. Last year, we have launched the MIR LED. As far as I know, it is the fastest detector in this wavelength. And now we have SIRIS. So the carrying range of the Lytid products has extended from terahertz to infrared. SIRIS, a high-performance scientific SWIR camera. You may ask what's new in SIRIS and why I should be interested in your product. Here is the answer. Our SIRIS is the very first camera can work in dual mode. It can work in the linear logarithmic mode. And it has a fully integrated cryogenic free cooler. As you can see here, our SIRIS gives a logarithmic response without a situation. In other words, it means we can have a really high dynamic. Since our SIRIS has a very advanced cooler, so we can work to a temperature very low. So it gives us a very low dark noise. In this way, we obtain a very long exposure time, more than 1 hour. Besides that, SIRIS supports the no-destructive readout mode. In this way, we can further suppress the readout noise. It's very helpful to detect the very weak signal. Last but not least, our camera is very fast. It provides 200 per second full frame rate. By reducing the region of the interest, we can obtain the higher frame rate. So the camera is great. We have seen the performance, but and in the following slide, I will show you some interesting results during the development phases. SWIR camera can be used in different fields, and I think the astrophysical observation is the most difficult one and the most high demanding. So we have tested in this field. On the left, you can see the nice picture of the observatory of Pic du Midi lying at the top of the Pyrenees in France. And thanks to the works of the Dr. Darson, we have obtained those beautiful pictures. Here you can see the Saturn and the Jupiter. Both of them were obtained with exposure time less than 1 second. It's very fast. And you can really see the details of the planet. The interesting thing is that you can even see the shadow of the Ganymede. Previously, I have mentioned our SIRIS can work in the line lock mode. It can give us a great dynamic. Here is we can see in this picture, the Jupiter and the Io is in the log mode, whether the other moon are in the linear log. linear mode. So in this picture, Jupiter is 22 million times brighter than the Tibet, and that gives us a dynamic more than 147 decibel. We also tested the non-destructive readout mode. Compared to the picture obtained in the normal mode, we can see the background noise has largely suppressed, and that allows us to detect the signal 6 times less bright. So it's really helpful, it's really advantageous to detect the weak signal. And the last, I will show you the 2 pictures of the Saturn. Attention here, the 2 pictures are from the one acquisition. In the left one, you can see the nice picture of the Saturn, and probably you can find the 3 other stars in the background. In fact, our series has detected more signal. To see that, we need to set the saturation value and inverting the grayscale. And here you can see there are more stars in the sky. This is a great example. It has shown the advantage of our camera, has a great dynamic. It has a very no noise. So our camera, the performance is proved by in this field astrophysics observation. So if it can work in this field, it can also works for the other high demanding application. So it can be used for the spectroscopy, for the medical imaging, or the laser diagnostic. We are look forward to find the partner to discover the potential of our series. So if you are interested in our product, I invite you to find more details on our website, or you can directly contact me.
Thank you so much, Mingming. Contact at lytid.com. This is a very, very innovative company. And I wanted to say that in the last 5 years, you really have made a difference. You won a Prism Award. You have been in the field of detectors, bringing terahertz to many different applications. You are a very important company in this ecosystem. But I had to ask you, because I signed a contract, what makes your product different from the competition?
As I mentioned before, there's a 2 points. Our camera is really the very first one camera. It can work in the link-lock mode. Besides, thanks to the very advanced cooling system, we have very low noise. So that can allow us to detect the weak signal, even with the presence of a strong signal without saturation.
I have many different companies in the room that I think they would have something to add to this. But before I go there, you are targeting a lot the scientific market. I get that in your presentation. Is there any reason for that? And which kind of R&D centers would you like EPIC to bring you in touch with?
Sorry, I didn't understand that.
Which you are looking to collaborate in the scientific market. So what R&D centers, what R&D research lines would you like to address with the EPIC members?
As I mentioned before, the SWIR camera can be also used for the other field, especially in particular, I think the medical imaging is a very interesting domain. We can discover more potential, more possibility in this field.
One more thing I would like to ask you. We are looking, of course, for partnerships here. So what kind of companies, what kind of challenges for R&D cooperation would you like to address with potential suppliers, partners, and system integrators?
For us, we are interested for the system integrated, especially if you have already the problematic and you want to provide a solution for the customer. In this way, our SWIR is ready to be integrated, and we can work on for the completed solution.
What is the next stage? Because in the beginning, you developed for first a sensor, now you're looking for a camera. What is the next thing? How are we moving light into a terahertz systems?
In our case, because it's our new product, we tested in the astrophysical observation in this domain, and we want to try more. For now, we have no imitation of the performance. We really want to prove our camera in other application.
Thank you so much, Mingming Pang. Thank you also all the speakers for this session. I would like to remind this meeting is being live streamed in YouTube and it's going to stay there for people to watch it later. If you want to get in touch with any of the participants today, all you have to do is send me an email, jose.pozo@epic-asset.com, and I will be more than happy to introduce you to all the participants, because at the end of the day, that's ultimately my job, to connect the industry. I also would like to remind everyone that for those of you who think that the meeting is over, the meeting is not over. Now is the most important part of the meeting, which is the follow-up. We are gonna get a lot of interest from some of these products. It was really, really, truly amazing. I was amazed by the ring shaper of Cailabs, so by the 349 nanometer CW ultra narrow line width of UniKLasers. Well, everything was really, truly fantastic. The femtosecond 2.8 micrometer laser from Femtum that was out of this world. We had the SWIR camera that actually is bringing by Lytid into the market, or the mid-infrared LEDs that Nanoplus brought into the market. It's quite fascinating meeting. Let me remind you, we have already the online technology meetings announced for the coming events. Please register on those, because we always publish the supply chain of the companies registered. You're an EPIC member, please make sure that your logo is there for all the particular events. So we have a fantastic team of EPIC experts, 15 people working at EPIC constantly, and many of them very well known by you, like Carlos. The others that you know less but you should know more. We have experts in every technology field. I would like to say that is almost spring. Almost spring. Wash your hands, wear a mask, because soon we're going to be traveling again, and I can't wait to visit all your companies and touch this technology that is making such a big difference for the photonic industry. Until the next time, bye-bye.